And I hope you guys are hearing my voice. There's nothing wrong with the voice. All right. Okay. So where were we? We talked about the normal distribution, right, guys? Z distribution, and we also solved some of those questions. Now we are going to change our topic to another statistical test, which is also very famous. Okay. Actually, you can think about this test that we are going to start this week is like the first statistical test that we are going to cover this semester. Okay, because in the Z distribution, we were generally comparing like a mean of a sample with a hypothetical mean of the entire population. Okay, or the imagined mean of the entire population. Okay, now with this test that we are going to learn today, by the way, its name is t-test. Okay, T as in Turkey. Okay, t-test. We will learn how to conduct tests on experimental groups. Okay, of course there are different types of t-tests, but in one of them we can conduct an experiment and collect our data and compare those two groups, and if there is a difference between them, or if they are the same, or that means if there is no difference between them. Okay, so that means we can actually learn how to conduct a test on a small experimental group. Okay, all right, then let me start our presentation first. I hope I didn't close anything. Looks like I did. All right. Yeah. Okay, showing the screen, yes. All right. Now, the test that we will talk about this week and the next week is called t-test. Okay, it's written here as you can see, t-test. However, there are different types of t-tests, like I said, and their names are simply, like here, there are 3 of them, like one sample t-test, and then dependent samples or paired t-test, you can call it, or independent samples, unpaired t-test. You can, yani ne oluyor? Tek örnek t-testi veya bağlantılı örnekler ya da çiftli testler veya bağlantısız ya da eşsiz ya da çift olmayan t-testler olarak gruplandırabiliriz. Okay. All right. Like we said, the name of the test is t-test, and in most of the statistics books, it is also known as the student's t-test, like a student test, sometimes they call it. And this student's t-test, don't think about it like this is a test for the students of the statistics, like it's for you. No, it's not for that purpose, of course. Yani burada it's not the reason that because the students are doing this test. Okay, the student is the nickname. Okay, nickname of this guy. All right, he called himself student in the past. So his name was like here is Gossett. Okay, and he published his test, this t-test, anonymously as student under the name of student. Okay, because he didn't want himself being known as the inventor of this test. All right, because why? There was some reason for that, because he was working for the brewers company Guinness. Okay, Guinness is like a beer company in, I don't know, maybe like Ireland or England, in some of those countries. Okay, because like a Guinness, although it's not like a nutrient, like alcoholic beverages are not called nutrient, but however, this is people drink them, right? And imagine a beer company using t-test at that time. All right, so that's why the Gossett wanted to keep his identity, because he didn't want other people or like the other companies, like competitors of the or other beer producers. He doesn't want them to know that the Guinness company is using statistics as part of their production plant or production system. Okay, so they were using the power of statistics to probably produce a better tasting beer at that time. Okay, so the test is used to compare samples from 2 different batches. Batches means like the production batches. For example, this batch, like the beer batch that you produce this week, and the next batch from the next week. Okay, so just to compare them and maybe see if their tests or if they're like a pH or other kind of features are equal or are they completely different. Okay, this is why they were using the statistics for their production purposes. Okay, it is usually used with small samples that are normally distributed. So what is important here? Oops, sorry about that. How come this got really big? Here, the important part here is that it is used with small samples, okay, that are less than 30, which is, what does that mean? That means like n equals to 30 or less, okay, 30 or less. And that are also normally distributed. What is normal distribution? Something like this kind of distribution, right? This might be called like a normal distribution. So let's give some more description about this t-test. All right. The t-test is a basic. Just laser. Yes. The t-test is a basic test. Okay, that is limited to 2 groups. Okay, so we can compare only 2 groups with each other using the t-test. If you have 3 groups, well, you need to think about more. You need to think about like deeper in that case. For multiple groups, you would have to compare each pair of groups. For example, with 3 groups, there will be 3 different tests. For example, comparing A and B, comparing A and C, and comparing B and C. However, it is not suggested, okay, for these 3 tests. Also, if you have 7 different groups, there would need to be 21 different tests. See, like you have 7 different groups and you want to compare each one of them, like with the first group, second group, and compare the first with the third one, first with the fourth one, first with the fifth one, sixth one, seventh one, and then do all the other comparison also, maybe well, the 5th group with the 6th group, 5th one with the 7th one also, okay? And if you do that, there are 21 different tests, 21 different t-tests are available. However, is it a good idea? Absolutely not a good idea, okay? It is not suggested. You should always compare 2 groups, okay? What is like, if I have 3 groups, can I not do t-test? Well, technically you can do t-test, but can I trust my results? Yeah, that is the problem. Because if you have more than 2 groups, your error rate will accumulate, okay? You remember our error rate? Like what was our error rate? Our error rate was alpha, right? Alpha, we were setting it maybe like 0.05. What does that mean? Like 5% error rate, like, right? The type 1 error, 5%. So with every comparison, for example, like A with B, A and B comparison, there's the 5% here. A and C comparison, there's another 5%. When you compare B and C, there's another 5%. So out of those, is my error rate is 15%? No, not exactly. We cannot say it's not additive. It's not 15%, but it is definitely at the time bigger than 5%. So it is between 15% and 5%. Okay, there is no way to find out what is your error rate at that time. Definitely, it is between 5% and 15%. All right. So since you cannot find out what is your error rate in this kind of t-test, like when you compare multiple groups, okay, therefore it is absolutely not suggested. T-test is suggested only for 2 groups, okay? Keep that in mind. For comparing 7 groups, for example, 3 groups, there are better tests to be done. However, we will not focus on those tests in the context of our course, because our course is like an introduction to statistics. If you are interested in those other tests, I would suggest you take more statistics course from the statistics department, okay, as elective courses, which will be very beneficial for you also. The basic principle is to test the null hypothesis, okay, that the means of 2 groups are equal. Okay, null hypothesis, like as in the normal distribution of the z-test, again, it is null hypothesis is always the condition of equality between the groups. See, there is no difference between them, and test it. The t-test assumes a normal distribution. Okay, therefore, you are using it on a parametric data, and underlying variances are equal. If not, of course, there are different tests to be used. Again, we are not going to focus on those different tests, okay? For example, for this test, I can tell you like maybe ANOVA might be a better idea to compare multiple groups in the beginning, okay? Okay, these are the assumptions: a normal distribution and equal variances, okay? Equal variances between the samples. It is used when there is random assignment and only two sets of measurements to compare. All right. So, like we said, there are different versions of the t-test, and we learned about them, like single sample t-test, independent sample t-test, and dependent sample t-test. In the single sample t-test, we have only one group. Okay, we have only one group, and we want to test against a hypothetical mean. Well, this looks exactly like our z-test, right? Z-table. You have one group, and you are comparing with the hypothetical mean. Well, what is the difference then? The difference is the number of n. Okay, in the z-test, your n can be like 100 or 200, 500. Okay, big numbers. However, in the t-test, your n is less than 30. Okay, so that means the only difference is your n. So if you have a sample, example, a question, comparing like a sample of 18 members, okay, then at that time you can think about the t-test. If you have 80, then think about the z-test, okay, because your n number is huge at that time. Independent sample t-test, we have two means and two groups, of course, and no relation between the groups, okay. There are no relation between the groups. This is the key here. For example, people randomly assigned to groups. In this case, you have two groups and you assign people randomly. For example, you have a new vaccine against coronavirus, and you want to test if your vaccine is working or not. And now what do? You gather like maybe like 20 people, and 10 of them you give your coronavirus shot vaccine, and the other 10 you don't give the vaccine. And maybe like 1 month later, you compare their blood samples, if there is any like antibody here or there is no antibody here, okay? So this is like an independent sample t-test. And with the dependent t-test, we have again two means, okay? However, for the two groups, it is not quite sure here, okay? We have, however, two means. Either same people in both groups, okay? Same people in both groups, or the people are related, or the samples are related in the two groups. For example, you can get like husband and wife couples, and for the husband, you test the husbands and you test the wives, okay, and you compare each couple between each other. For example, me and my wife, and then you get the results from us and compare them. And another group, another couple, and you get the couple and compare them. You get the couple and compare them, okay? Or for example, left hand and right hand, like a same person and doing maybe stuff like some experiment with right hand, and the same person doing the experiment with left hand. And see, you're trying to compare the same person, their hands in this. Or could be another maybe like hospital and the visitors, okay? Like the hospitals and the visitors, okay? Because visitors are going to that hospital. There is a relationship between them. Understand? Applications, when we look at them, to compare the mean of a sample with population mean, this is the one sample t-test. To compare the mean of one sample with the mean of another independent sample, okay, this is independent t-test, or to compare between the values of one sample but in two different occasions. Bir örnek grubunun iki farklı zamandaki değerlerini ölçmek mesela. Sınav yapacağız mesela. Dönemin başında bütün arkadaşlara mesela sınav yapıyoruz. istatistik sınavı. Tabii herkes dökülüyor. Dönem sonunda istatistik dersini verdikten sonra yine istatistik sınavı yapıyoruz. Tabii yine herkes dökülüyor. Değil mi? Tabii bu işin şakası ama ne olacaktır? The students will probably do worst in the first exam in the beginning of the semester, and after the semester they will do better in the same kind of statistical examination because they learned. However, they are the same people. Okay, we didn't change the people. Okay, this could be the dependent sample t-test. Okay, why is t-drift distribution now? Then because z distribution also almost the same thing, right? Z distribution is also a normal distribution, same thing. The difference is that, like I said, the number of n. Okay, let's check here. Okay, we have the number is less than 30 in the t distribution. Why is it so important? Here, look at this distribution graphs here that we can see. Okay, the z distribution is shown in the blue one. Okay, z distribution, standard normal. If you remember, when we have this kind of distribution, or to obtain this exact z distribution, what do we need to do? We have to have an infinite number of sample size, right? Infinite number of sample size, so that it will be symmetrical around the mean. Okay, mean would be 0 in this case. However, for the t distribution, if you notice, it is the same kind of distribution, like symmetrical. However, it is not exactly like normal distribution, like z distribution. Why? Because the mean point is lower compared to the z. Look at, for example, when you have 30 samples, okay, n equals to 30, your mean point would be lower. And if you look at the tails would be fatter than the normal distribution, okay, standard normal distribution. See, the tails are very thin going here. If you notice, remember, they never touch the axis. They go all the way to the infinity. If you remember, this blue line goes all the way to infinity. Same thing with the purple line. The same purple line also goes to the infinity. However, the tail is fatter. Kuyruklar daha şişman. Standard normal distribution'a göre. Okay? And if you reduce your sample size even less than 30, okay, then your peak level at the mean area would be even lower. Like it was higher, lower, and lower. How it is becoming lower? When you decrease the number of samples. Okay, see, around 30 and smaller than 30. See, what about the tails? Tails are now even fatter. Okay, even fatter. Daha kalın kuyruklar var artık burada. That is the difference between standard normal distribution and the t distribution, guys. Okay, the only difference is the mean is not so high, it is lower, and the tails are fatter. Daha şişman kuyruklar var. Okay, this is the difference between standard normal and the t distribution. Here also notice that as you can, with the t distribution, as you decrease the, I will explain this one later on, this df. Df means decrease of freedom. Yani in Turkish it means özgürlük derecesi. Okay, as you decrease your degrees of freedom, your peak point is dropping less and less. And as they get less, your tails are gonna get fatter. Okay, your tails are gonna get fatter in that case. In this animation, what you can see is, now, let me just try to understand. Look at the n number here. The n value starting from 10, 20, 30, 40, 50, 60, and always gonna go to 100. And as the number of sample increases, look at the distribution. See, distribution is wider, flatter. Now it's becoming like more like pointy. The peak is increasing greatly, and the tails are thinner at that time. In the beginning, if you notice, tails are fatter. Now tails are becoming thinner. This is showing us a normal distribution, how the normal distribution is changing with the increase of sample size. Okay, so as you increase the sample size, your distribution will become more like standard normal distribution. So let's draw this for ourselves. Okay, if this is the distribution, okay, if for example, under the, let's call them n equals 10, our distribution would be something like probably this, n equals 10. When we increase the n equals maybe like a 30, our distribution would be, okay, would be something like this. All right, well, I didn't draw it perfectly, but when you increase the n equals 100, maybe your distribution will be even thinner in the tails, okay, and higher in the mean area. Okay, this is the difference. Well, my drawing is not perfect, of course, and so therefore this distribution is showing us the better results for us. See, as the sample size is increasing and increasing, your distribution is becoming more like pointier. See, now this with the red line, you can see it like it's now becoming normal distribution, even greatly. See, look at the tails are this narrow. In the beginning, it was something like this, right? And then they becoming thinner, and the midpoint is also increasing. How we understand that? Because of these numbers. See, look at those numbers. All right. All right, let's talk about the degrees of freedom now. Özgürlük derecesi. Because with the t-test, we need to learn about the degrees of freedom. Degrees of freedom is the number of values in the final calculation of statistic that are free to vary. Okay, this is the definition. Neymiş Türkçesi bu olan o zaman? Yani en son istatistik hesaplamalarında değişmesi ne diyor? Değişmek için özgür olan değerlerin sayısı. Bu ne saçma bir ifade. Değişmek için özgür olan değerlerin sayısı ne demek yani? I will show you with a small example now, guys. Okay, now you have your GPA, right? You have your GPA or the GANA, your GANA. For example, let's calculate my GANA. Okay, this is my GANA in maybe like after semester and semester. In my first semester, okay, my GANA is, for example, let's call it like 1.0. Okay, I wasn't a good student. In my second semester, my GANA became like the entire overall grade average. It became like 1.5. Okay. In my third semester, it became like 1.6. In my fourth semester, it became 1.8. Okay. Now, how are these happening now? That means let's look at my semester mean averages. Okay, for the semester. Ona ne deniyor? Ona da DANO deniyor değil mi? Yani tuhaf bir şey. Dönem akademik not ortalaması. Okay, let's imagine what are my DANOs compared to the GANOs. Okay, definitely in my first semester it is 1.0. In my second semester, probably my DANO was about 2.0, and then it became 1.5, the overall general average. And then for the 1.6, it was probably like 1.9 for the semester average. For the 1.8, it was probably like 2.4 or something. So my average became 1.8. Okay, now this is my entire overall average. Now let's imagine my samples. What are my samples? My samples are these. Okay, these are my samples because they are each grade averages for different semesters. Okay, my N is 4. 4. Okay, now, how many of these samples are free to vary? Look at here. My first semester average is setting up the point. Okay, it tells us your average is 1. Now, what I am doing is by addition of the other semesters, adding other semesters, I'm trying to change this average. Okay, in the first semester average is setting up the value. Okay, yani birinci dönem ortalamanız sizin kaderinize bir çentik atıyor. genel not ortalamanızda bir çentik atıyor. Artık o kaçsa. Ve bundan sonra gelecek olan bütün dönemler o seviyeyi yukarı ya da aşağıya çevirmek için hareket yapacaklar. Değil mi? Notlarına göre. So, kaç tanesi o zaman burada değiştirme özelliğine sahip? Kaç tanesi değiştirememe özelliğine sahip? Birincisi değiştiremiyor. Birincisi setup yapıyor. Diğer bütün dönemler bu değeri değiştirmek için gitti sayfa. Senin genel ortalamanı değiştirmek için güçlerini ortaya koyuyorlar. Diğer bütün dönemler. Therefore, what happens now? Your N is, for example, 4 in this 4 semesters, right? However, your degrees of freedom is 4 minus 1 semesters, which is equal to 3. Why? Because, like I said, the first semester is setting up the value, and after that, the second, third, and the fourth one, they are all trying to change the average of your first semester. Okay, this is the mindset. Okay, this is the idea that you need to think about it. Okay, degrees of freedom is always, let me just write here, degrees of freedom is always n minus 1. Okay, however, this is general. And if you remember, we have 3 different t-tests, like one sample t-test, independent sample t-test, dependent sample t-test. Is it always n minus 1? Yeah, a little bit. In the dependent sample t-test, it changes a little bit, but generally it is n minus 1, okay? Also, in the independent sample t-test, it changes a little bit too. But this is a general formula, but it will change, okay? Think about it, it will change. Okay, I'm not gonna go over this slide anymore. You can read it, and it's telling exactly what I tried to show you with the example, okay? And if you learn with this reading, it's better. You can read it then later on. Okay, let's look at a case study for the one sample t-test. It is used in measuring whether a sample value significantly differs from a hypothesized value. Okay, it is used in measuring whether a sample value significantly differs from a hypothesized value. For example, okay, a research scholar, let's get the eraser. A research scholar, ne demek bu? Bir araştırma alimi, yani araştırmacı. A research scholar might hypothesize that on an average, it takes 3 minutes for people to drink a standard cup of coffee. Yani demek ki çok büyük bir bilim adamıymış. Artık insanların bir bardak kahveyi ne kadar sürede içtiklerini bile düşünmeye başlamış. Okay, he hypothesized that it takes about 3 minutes. Yani normal bir insan normal bir kahveyi 3 dakikada içer diyor. Bu onun fikri. He conducts an experiment and measures how long it takes his subjects to drink a standard cup of coffee. The one sample t-test measures whether the mean amount of time it took the experimental group to complete the task varies significantly from the hypothesized 3 minutes value. Okay, so what does he do? He maybe goes around and maybe buys coffee to his friends, maybe 7 friends, and then he measures how long it's going to take them to drink the coffee, right? He gives the coffee, and then he starts like a chronometer, and then measures them. Okay, yeah, go ahead, you drink your coffee, don't worry about it. No, don't talk, just drink. Şimdi lafa tutarsa da bu sefer uzun sürecek kahve içmesi, değil mi? Arkadaş da diyecek ya bu ne yapıyor? Kaldı bana kahveyi, geçti karşıma oturuyor. İnsanlar da bir tuhaf olacaklar. Neyse, they don't think about it. So he measures like 7 different people and measures how many minutes it takes them to finish the coffee and gets an average. Maybe the average is like maybe 3.2 minutes. He was thinking 3 minutes. Now he measured 3.2 minutes. Okay. His hypothesized value was 3 minutes. Maybe his result will be 3.2 minutes. Okay. Now he's going to conduct a test. If 3.2 minutes is different from the 3 minutes. Yani okay. Şimdi de bu 3.2 dakikanın 3 dakikadan farklı olup olmadığını test edecek. Neye göre? Standart sapmaya göre, of course, right? Using the one sample t-test. Let's look at another case study for the independent sample t-test, unpaired t-test. The independent sample t-test procedure compares means for two groups of cases. Okay, means of two groups. For example, patients with high blood pressure, okay, yani yüksek kan basıncına sahip olan insanlar, değil mi? Ya da tansiyon da diyebiliriz buna. Tabii ki tansiyon da diyoruz Türkçe. Patients with high blood pressure are randomly assigned to a placebo group and a treatment group. Treatment group ne? Onlara tedavi uygulayacaklar. What is placebo group? Placebo group onlara da bir şey uygulayacak ama tedavi değil. Yani hani şey gibi bir gruba aspirin veriyorsun baş ağrısı geçsin, öteki gruba da bonibon veriyorsun. Hani onlara hiçbir şey vermiyormuş gibi gözükmemek için. Çünkü bu insanlar konuşacaklar. Doktor sana ne verdi? Bana bir hap verdi. Sana ne verdi? Bana bir şey vermedi. Vay çakal doktor. Bana niye vermedi? İşte bunlar olmasın diye you treat an individual one of the group as placebo. For example. Mesela geçenlerde ne olmuştu? Aklıma gelen en büyük örneklerden bir tanesi. Teknoloji Bakanı mesela şimdi biz Erciyes Üniversitesi'nde güzel bir çalışma var ve aşı geliştiriliyor şu anda, yani kendi yerli aşımızı geliştirmek için bu koronavirüse karşı. Haberlerde görmüşsünüz mesela. Teknoloji Bakanı da bu faz 2 çalışmalarına denek olarak katılıyor gördüğünüz gibi. Ama burada Teknoloji Bakanı'nın gerçekten aşı mı vuruluyor yoksa sadece tuzlu su yani placebo mu vurulup vurulmadığı bilinmiyor. Bunu bakanın kendisi de bilmiyor. Biz de bilmiyoruz tabii ki. Sadece orada aşı vuruyorlar. Ama gerçek aşı mı yoksa placebo mu vurulduğunu burada deneyi yapan doktorlar biliyor sadece. Tabii onlar da söylemiyorlar. Onlar da gizli tutuyorlar ki bünyesinde antikor oluşacak mı oluşmayacak mı ona göre test edecekler. Okay? For example, this is like a placebo or treatment group. The placebo subjects receive an inactive pill, okay, and the treatment subjects receive a new drug that is expected to lower blood pressure. Okay, they are comparing now their new drug. The two sample t-test is used to compare the average blood pressure for the placebo group and the treatment group, and then they are measuring the blood pressure of two groups, different people from the two groups, and compare their blood pressures. Maybe, for example, are the people in the new drug, do they have lower blood pressure, or do they have the same kind of blood pressure compared to the placebo group? Okay, this is the comparison now. For the paired sample t-test, let's look at a case study. It is used in comparing the means of two variables, okay, for a single group. Two variables for a single group. See, the group is single group. This test computes the differences between values of two variables for each case and tests whether the average differs from zero. Average differs from zero. İki ayrı zamanda ölçümler yapılıyor ve aradaki fark sıfır mı? Yani hiçbir değişiklik yok mu? Gibi. Dönem başında istatistik sınavı yapıyorsunuz. Bir de dönem sonunda istatistik sınavı yapıyorsunuz. Yani her öğrencinin aldıkları notlarda artış ya da azalış var mı? Ya da sıfır mı? Sıfırsa o kadar anlattığınız 14 hafta, 15 hafta istatistik dersi boşa gitmiş anlamına geliyor. Okay? For example, in a study on impact of a particular diet on weight. Okay? Diet on weight. Yani bir diyet tarzı var, özel bir diyet. Bu diyetin kilo üzerine etkisini çalışan bir çalışma. All patients are measured at the beginning of the study. Okay, they weigh their kilograms. Okay, and they are prescribed a fixed diet. Her birine aynı sabitlenmiş diyet veriliyor. Aynı diyet veriliyor. Diyor ki sabah şunu yiyeceksin, öğlen bunu yiyeceksin, akşam bunu yiyeceksin. Bu kadar. And diyor ki 2 hafta sonra geri gel. And then they measure them again after the time period finishes. Thus, each subject has two measures, often called before and after measures. Okay, this is a giveaway. Okay, giveaway. Bu ipuçlarından bir tanesi. Eğer datanızda before after örnekleri varsa çok büyük ihtimalle paired sample t-test'ten bahsediyorsunuz. Okay, you're talking about paired sample t-test at that time. If you have a data with the points of like before measurements and after measurements, all right? Okay, how are we going to do this t-sample t-test now? First of all, we need to know the sample mean and the population mean. All right. The general steps of testing hypothesis must be followed. How? That means that we have to set up a null hypothesis. We have to set up an alternative hypothesis, and we need to also know the degrees of freedom in that case. This is the general formula for the t-statistics. Very simple looking. However, it will become nasty later on. For example, a null hypothesis could be sample mean is equal to population mean, or sample mean is equal to the hypothetical mean. All right. An alternative hypothesis would be sample mean is not equal to population mean, or if you don't want to write it long version, you can write in the short version like not 80. Yani yukarıdaki değil anlamına geliyor. Degrees of freedom, like I said, it is n-1. And the t calculation, the t statistics calculation is x bar. What is this? This is the sample mean. Okay, x bar is the sample mean. And then mu is the population mean divided by standard error of the mean. Now, what is this SE? Let's learn about it. What is that SE now? Okay, let's look at a small sample. The following data represents hemoglobin values in grams per deciliter for 10 patients. Okay, 10 tane hastanın kanındaki hemoglobin değerleri var elimizde. Here like 10.5, 9, 9.5, and 12, and all of them. Is the mean value for patients significantly differ from the mean value of general population? Demek ki biz insanların sahip olması gereken ortalama hemoglobin değeri rakamını biliyoruz. This is 12 grams per deciliter. Now we are comparing, is the mean value of these patients, okay, these patients significantly differ from the mean value of the general population. Evaluate the role of chance. First of all, what do? We need to calculate the x bar. Okay, that means the average of this entire 10 people. All right. Here is the x bar, 8.95. All right. And then minus the population mean, which is 12, which we know already, divided by the standard error of the mean. What does that mean? This is standard deviation. Okay, I will just write it this way. Standard deviation divided by square root of n. Okay, standard deviations divided by square root of n. Standard deviation of this entire sample, okay, divided by, since we have 10 people, square root of 10. All right, and then this is the value we find out, minus 5.352. What does that mean now? Minus 5.352. What does that mean? This is the t statistics. Okay, we write it generally this way. T statistics is equal to minus 5.352. Sorry, 2. Okay, now this is the statistics. This is a calculated t. We calculated it, and then compare this t statistics with the tabulated t value. I will write it here like tabulated t value. Okay, for degrees of freedom 9 and 5% level of significance. Okay, and it is 2.262. Now you're going to tell me, how did you come up with this 2.262? This is crazy. I don't know how to find that out. This is how. First of all, we need to know the degrees of freedom. Remember, degrees of freedom always n-1. Okay, n is 10, and 5% level of significance. What is that? This is my alpha level. Did they tell me anything about alpha level in the question? No, they didn't tell anything about it. So I can choose my own alpha level. Let's alpha level, take the 0.05. Okay, perfect. And then what do? Now we need a table. What table? We need a t-table. Okay, t-table is right here. Remember the z-table, the normal distribution table? We have exactly the same kind of table, but it is called t-table. Look at top here. It says, oops, sorry about that. Let's get the pen. I hope it works this time. See, it says, but look at that here. It tells us upper percentage points for the student t distribution. So that means for any kind of t value, it is given me this upper percentage, okay? The area under the curve to the right of the t, to the right of t value, okay? To the right of t value. Now I need to find out my t value from here. What is my alpha? Alpha is, we talked about that, it's 0.05. Sorry about that. 0.05 alpha. This area is alpha. Now, if you look at it, now how we are going to use the table. If you notice, the table has this top part and also a vertical section here. Okay, what are they? The vertical section is the degrees of freedom. Okay, the top part is the alpha, like you said, like you see. And since our alpha is 0.05, now let's look at the 0.05. This is too small, 0.05. This is 0.05. Here, 0.05 is here. This is my alpha, 0.05. That means we are interested in this column, okay, because this is 0.05 alpha level. Now, what is this? This was the degrees of freedom. Our degrees of freedom is 10 minus 1, which is 9. Okay, this is degrees of freedom. So that means we will continue this and okay, find out here, 1.833. Now I understand, I'm seeing now some of you guys are saying me, well, that wasn't 1833 in our example, right? You guys are telling me that it is 2.2626, sorry, 2.262. It's not 1.833. So how is that possible? Okay, let's read the question then again. All right. The question is telling us, is the mean value for patients significantly differ from the mean value? Okay, this is the keyword. Differ from. What does differ from mean? Let me just open up. Sorry guys, open up a white slide with you because I don't want it to be lost. So now we are talking about the significantly differ from. What does differ from mean? Differ from means, like, sorry about that. Differ from means, if the sample mean greater than the population mean, does it mean it differs from? Yes, right? Is the sample mean is smaller than the population mean? Does it mean it differs from? Yes, also. What is the not differ from mean? It means if they are only equal, this is not differ from, right? It doesn't mean differ from. Differ from has two options. See? It says differ from. Yani diyor ki hastaların kan değerlerine, hemoglobin değerleri genel popülasyonun hemoglobin değerinden farklı mıdır diyor. Farklı olmak nasıl olur? Ya düşük olursun ya yüksek olursun. Okay? Now think about that. You can be either low or you can be higher. All right? So then let's imagine our t distribution. Remember, this is the 0. Okay? This is the t distribution. This is the negative side. This is the positive side. Okay, when you are lower than the population mean, where are you? you are in this tail. When you are higher than the population mean, here, let's write here, X bar is less than mu, you are in this area. When the X bar is greater than mu, you are in this area, correct? So differ from, if the differ from means 0.05, then we have to divide it by 2, guys. And we have to give 0.025 in this tail, 0.025 in this tail. And let's look at some values here. There is a certain t value here. This is a positive t value, this is negative t value. And the area under the curve is 0.025, and area under the curve to the right of this plus t is 0.025. Okay, so the summation of these two tails should be equal to 0.05. Okay, the summation of these two tails. Yani Türkçesini söyleyeyim, %5 hata yapma şansı değil mi? %5 hata yapma ne diyelim tampon değerimiz var, değil mi? Ya da hata yapma ihtimalimiz var. Ve biz bu hatayı sorumuzda bize farklı mıdır dediği için, farklı olmak iki şekilde olur. Ya küçük olur ya büyük olur. O zaman bir %5'lik hatamızı iki tarafa da eşit olan yani vermek zorundayız. Okay? %2,5 küçük olma, %2,5 büyük olma. Ya da size göre %2,5 küçük olma, %2,5 büyük olma şeklinde. Alright? Therefore, my alpha level is equal to 0.05. However, in my t-table, I will look at it, my alpha divided by 2, which is 0.025. Okay? Yani t-table'da ben 0,05'e değil de 0,025'e bakmak zorundayım. Çünkü iki kuyruğa bölmek zorundayım hatamı. Now, let's go to the t-table one more time. I will get the eraser. Beep, beep. All right. What is my alpha now? My alpha is 0.05. But now that I know, I need to give another alpha level here. This is the minus t. This is the plus t value on this side. So that means this area is my alpha divided by 2. This is also alpha divided by 2. My alpha is 0.05. Therefore, the value is that I'm actually interested in is alpha equals 0.025. To find out this t value here, 0.025. Now my value is here, 2.262. Understand? This is the actual t now. %5 hatayı iki tarafa yayarsam o zaman %2,5 hata bakmamıza gerekiyor. Alright. Since my alpha level t value is 2.262, what does that mean? Okay, let me just explain that as well. I will just go back and erase everything here. Okay. Again, let's show the t distribution here. This is the 0. That means, sorry about that. This is my plus t value, which is 2.262. This is my minus t value, which is minus 2.262. And the area under the curves are here. Okay. What does this mean? This is alpha divided by 2. This is alpha divided by 2. That means like 0.025. Same thing, 0.025. Okay. Now, let's find out my calculated t value. Calculated t value is minus 5.352. Okay, this is the t value that I get from the data point, from my data, actual data, minus 5.352. Where is it? Where is minus 5.352? It is here, right? It is probably here. This is minus 5.352 something. Where am I? I'm in the shaded area. Okay, this goes all the way. That goes also all the way. Where are we? We are in the shaded area. What does that mean now? Okay, to understand here, this area in the middle, the white area, is not reject H0 area. And the shaded areas means reject H0 and reject H0. Okay, the shaded area means reject H0. So therefore, if our calculated T value falls into the shaded areas in the tails, okay, which are very low percentages, like 2.5% rejection areas, then we reject our null hypothesis. Okay. However, if our calculated T value was here, maybe like minus 1.2, for example, burada olsaydı, we were not gonna reject the null hypothesis. Okay. However, it is here, minus 5.3. So that means the calculated value is greater than the tabulated value. Tabulated bu şeyden, yani tablodan elde ediliyoruz, yani tabu. Hani bir tabu diye bir kelime vardı biliyorsun. Bu tabu olan T değeri. Tablodan gelen T değeri. Yani bu kural. However, if our calculated T value, which is this one, greater than the tabulated value, okay, then reject null hypothesis, H0, and conclude that there is a statistically significant difference between the mean of sample and population mean. And this difference is unlikely due to chance. When was it going to be likely due to chance? Here. If the calculated T value was here, diyecektik ki yine sıfır değil. Yani tam ortaya denk gelmedi. Arada fark var. Okay? Ama bu şanstan dolayı olmuş olabilir diyecektik. Ve we were not gonna reject the null hypothesis at that time. Okay? And if you remember, by the way, we didn't write the null hypothesis and the alternative hypothesis in this question, but always remember, null hypothesis is the equality, always has the equality in it. So that means null hypothesis would be the mean hemoglobin value for the patients equals mean hemoglobin value for general population. Okay, that would be the null hypothesis. And this is another T table that can be shown. However, in this T table, you can, if you notice the degrees of freedom again on the left-hand side, you can see them. However, on the top part, the significance level, alpha level, now we have two lines. One of them says like two-tailed t-test, and the other one says one-tailed test. So, depending on the type of the test, the type of table, it doesn't matter. So, in this case, if we had this kind of table, how are we going to use it? Again, 9 degrees of freedom would not change. Okay. And our alpha level was again 5%. Remember? Well, will it be this 5% or will it be this 5%? It will be this 5%. Why? %5 hata payımız var ama testimiz 2 kuyruklu oldu. 2 kuyruk ne demek? Eşitlik var. Yani bir T değeri varsa elimizde, we are looking at both tails. Okay, this means two-tail test. All right. Sometimes we do the one-tail test, and I will also show you those ones later on. No problem. So therefore, we look at the two-tail t-test for 5% error rate, significance level, and then find the same 2.262 again. All right. The tables don't change. The numbers don't change. Let's look at the dependent test. When we have two dependent or related samples, for example, same group measured twice, like time 1 versus time 2, or pre-test, post-test, and testten önce, testten sonra, okay, samples are matched on some variable. Each score in one sample is paired with a specific score in the other sample. Such data are correlated data. Example of research questions are something like this. Is there a significant difference in students' mathematics achievements when taught through traditional methods and hands-on problem-solving methods. For example, you are teaching two different methods to teach mathematics to the students, and you are using different methods. One of them is traditional methods, and the other one is hands-on problem-solving methods. Traditional method ne? Belki şu an yaptığımız gibi işte anlatıyoruz, siz dinlediniz, dinlemediniz, bitti gitti. What is hands-on problem-solving method? This is the actual one. Mesela sınıftayız, herkes mesela soru veriliyor, kendilerine özel soru veriliyor. Hadi bu soruyu sen çöz gel mesela haftaya. Herkes kendi sorusunu çözüyor, geliyor ve ne oluyor? Daha iyi öğreniyor belki. So, in this case, independent variable would be the method taught, okay? It could be like values would be traditional, baseline, or the hands-on problem solving is the other method. And dependent variable, yani bağımlı değişken nedir? Mathematics achievement. For example, the scores of the students in a test. Okay, and it's a continuous variable, by the way, if you notice, because the scores are measured in the continuous way. This is called dependent variable because it is taught that mathematics achievement is dependent on the method that is used to teach the students, like a traditional method or the hands-on problem-solving method. That's why it is called dependent variable. Another example, is there a significant difference in morbidly obese students' pre-exercise weight and post-exercise weight? Demek ki neymiş? Okay. Diyor ki soruda, ölümcül derecede obez öğrencilerin diyor, yani demek ki sınıfta gayet aşırı kilolu arkadaşlar var. Bu öğrencilerin diyor, egzersiz öncesi ağırlıklarıyla egzersiz sonrası ağırlıklar arasında significant derecede, yani önemli ya da anlamlı derecede bir fark var mı? Okay? Rather than comparing the means of the pre and post, we compare the pre and post scores for each individual. All right. So in this case, independent variable will be time, like a pre and post, and dependent variable will be the weight of the students. For example, their weight in pounds, in kilograms, and also it's a continuous variable. All right. In this case, for the one sample t-test or dependent sample t-test, what are we going to do? Same things again. State the hypothesis first. Hypothesis, of course, there is a null hypothesis. In this case, null hypothesis, we will go with the difference, guys. For example, null hypothesis will be the mean difference is equal to 0. Or it could be, you can write it to say, the alternative null hypothesis is the mean difference is equal to 0 or greater than 0. Or mean difference is equal to 0 or less than 0. Because if there is an expectation that you know already. So depending on these null hypotheses, alternative hypothesis would be not equal to 0 because it has to be exactly opposite of it. If the mu difference is equal to 0, alternative would be mu difference is not equal to 0. Otherwise, mu difference is greater than equal to 0. The exact opposite of that is smaller than 0. Smaller than or equal to 0, exact opposite of this is greater than 0. Okay? In this case, the subscript D, the small d, or the subscript capital D indicates the difference between the samples. Okay? Mu difference. Difference, yani farkların ortalaması. All right? After that, writing the null hypothesis, what do? We set the criterion for rejecting the null hypothesis. For that, we need to find out the degrees of freedom. Degrees of freedom, like remember again, n-1. However, independent sample t-test n is equal to number of pairs, not the number of sample. Okay, number of pairs in this case. Set the alpha level, which is very simple, for example, 0.05, just say it. And locate the critical values. Critical T. Okay, now, what are these? This critical T. Okay, let me just give you some more example. Critical T equals to, also sometimes it's called tabulated t. Okay, critical t sometimes is also called tabulated t. Another one, t-statistics t-statistic is equal to the calculated t. Okay, these are two different things. We are going to compare this value with this value. Okay, they have different names of course. Critical t yani ne diyor yani eşik t değeri, kritik t değeri. Hani hangi değeri aşarsan işte o eşikteki değer. Or tabulated t value. We get these values from the t table. Okay, and the other values down there, we are getting these values by calculation. All right, now compute the test statistics, which is the t-statistics. Okay, or it can be said sometimes calculated t value. All right, here, the difference is x2 minus x1, which is like a after minus before. Okay, in this case, d bar is equal to sum of all the d's divided by n. Okay, sum of individual differences in this means. All right, and the standard, how can we say this? Standard error of the mean difference is equal to sample standard deviation of SD, okay, difference scores divided by square root of n again. Okay, standard deviation of difference scores divided by square root of n. In the end, our t value is here. T value is d bar divided by standard error of the d bar. Okay, how are we going to calculate this standard error of the d bar? Here it is. Standard deviation of d divided by square root of n. N is the number of pair. Okay, number of pair, if you notice, remember. Let's look at a small example. Here are some before and after values. Like before values is like 58 something, 584378, and after values are 6956 and then we find out the differences. Difference is after minus before. Well, depending on however way you can do it. You can do before minus after, doesn't matter. After minus before, you get these values like 111, 301, 02, and then here is the summation of the differences is 8, okay, and the d bar is of course 8 divided by 6 because there are 6 pairs like 1, 2, 3, 4, 5, 6 different pairs. 8 divided by 6, which is 1.3. Okay, this is the d bar, and standard error of the d bar is standard deviation of the difference. Okay, standard deviation of difference, which is 103. If you do the calculation, şu değerlerin standart sapmasını hesaplarsanız 1,1,302'nin you will find out 1.03 divided by square root of 6, which is 0.42. And find out to calculate the t is d bar 1.3 divided by 0.42 is 3.09, for example. This is your statistical t value. All right. Okay, now compare the test statistic to the criterion. Use t distribution in the appendix to find the critical values given alpha level and degrees of freedom and directionality of the test. Directionality of the test. Let's find out if there was any direction. Well, they didn't give us any direction, right? In the question, they didn't give us. All right. So in this example, degrees of freedom is n minus 1. N would be the number of pairs. So there are 6 pairs minus 1, 5 different pairs. So a degrees of freedom is 5. Okay. And use t distribution table to find the critical values given alpha level, degrees of freedom, and directionality of the test. The graph on the right shows an example of two-tailed test with the critical value equal to plus or minus 309. Okay, 309. So How are they finding the 309? Let's find it out. Our alpha level was 0.05, okay? Because in this example, I didn't show you the directionality of the test, but because they are showing like the two tails for us, it is we are looking at the null hypothesis is equal, like the difference is equal to 0. There's an equality here. Okay, alternative hypothesis would be difference not equal to 0. Okay, difference not equal to 0 means, what does that mean? That means that difference can be negative value or difference can be positive value. All right, it could be greater than or smaller than. So there are two options. When there are two options, we divide the alpha level by 2. Okay, that means we have to divide our 5% error rate in two tails. One of them is the positive side, the other one is the negative side. Let's go back to the T table. Okay, erase everything here. Now let's try to find out what was our degrees of freedom. There were six pairs. This degrees of freedom is 5, and alpha level would be in this case 0.05. However, since we are going to divide it into two tails, it's 0.025. Okay, here it is. It is 2.571 in that case. Let's go back. This 309, we are putting our statistical T 309 in this way. So what does that mean? These are our critical value, and we find out the alpha level 0.05 and degrees of freedom 5. The critical values are 2.571. So what does that mean? Actually, this means that 2.71 here, 2.571 here, okay, minus and plus ones. So that means these are the tabulated value. So that means if your calculated T value is in the shaded areas, you reject the null hypothesis. Because our T statistics is greater than the tabulated T value, we reject the null hypothesis. Okay, this is another way of solving the dependent sample t-test. Okay, another example here showing us the blood pressure of 8 patients before and after treatment. Here, blood pressure before these values, blood pressure after these values. If you notice, there is like a reduction, right? 180 to 140, 200 to 145, 230 to 150. Okay, and then you find out the differences. Differences are here for the 55, okay, and the sum of the differences. Then you calculate the D squared, and let's continue. And from this sample, the T value is calculated to be 9.38387. This is the statistical T value or calculated T value. Okay, 9.387. The tabulated T value is for the degrees of freedom 7. How is that? Because there are 2, 4, 6, 8 pairs. 8 pairs of sampling done here. Okay, 8 minus 1 is 7. Degrees of freedom 7. Significance level of 0.05, and it is 2 tails. That means in the alpha, we will look at the alpha divided by 2 in the table, and this is the value that we find out, 2.36. And imagine again, put the tabulated T value 2.36 minus 2.36. This is the 0. And if our calculated T value is in the shaded areas, then we reject the null hypothesis. What is our calculated T value? 9.387, which is all the way here, like 9. So definitely reject the null hypothesis in this case. So here it is. We reject the null hypothesis and conclude that there is significant difference between blood pressure readings before and after treatment. Definitely there is a significant difference between them. Okay, and what is your significance level? 0.05. because this is what we choose our level of significance. Okay, the p-value. Yani ne demek? Olasılık. Olasılık anlamına geliyor. P-value, a number. Alright, I will also explain this one and then finish after the independent sample t-test, guys. Okay? Okay, in this independent sample t-test, the reason for hypothesis testing is to gain knowledge about an unknown population. All right, independent samples t-test is applied when we have two independent samples and we want to make a comparison between the two groups of individuals, and the parameters are unknown in this case. Right, what does that mean? That means like we have only sample A and sample B. However, we don't know their population, where we got them. We don't know if they are equal or not. So how are we find out? We can only have these samples and compare these two samples. This is what does it mean? How is this different than a z-test and one sample t-test? Think about it. How? By the number of sample size, of course, right? Sample sizes should be less than 30 in this case. Independent t-test, we are interested in the difference between two independent groups. As such, we are comparing two populations by evaluating the mean difference. In order to evaluate the mean difference between two populations, we sample from each population and compare the sample means on a given variable. Okay? Must have two independent groups to do this kind of test. We have to have two independent groups, okay, or samples, and one dependent variable that is continuous to compare them on. Okay, we have to have two independent groups and one dependent variable measured from each group to compare them. Değil mi? Mesela ne olabilir? Felsefe öğrencileri ve mühendislik öğrencileri, iki ayrı grup, and then we can put them in an exam and then measure their exam scores and compare if there's a difference between the success of the philosophy students and success of the engineering students, right? Example, do males and females significantly differ on their level of math anxiety? Mesela bu bir tane soru olabilir. Math anxiety ne demek? Matematik endişesi. Yani diyor ki erkeklerle kadınlar matematikte yaşadıkları endişe dolayısıyla birbirlerinden farklılık gösterirler mi? Bu niye yapar? Mesela ne diyoruz belki? Mesela kadınlar matematikte daha iyi gibi bir yaklaşım çıkarmaya çalışan bir testin başlangıcı olabilir bu soru. Okay? In this case, our independent variable is gender. We have two groups, males and females. Our dependent variable would be the level of math anxiety. Tabii matematik endişesi nasıl ölçülür? Onun bir tahminim yok ama ne yapıyorlar mesela? Arkadan gizlice yaklaşıp böyle matematik diye bağırıyorlar mı acaba? Hani böyle korktu falan. Bak demek ki çok korkuyor. Öteki de matematik diye bağırıyor, o gülümsüyor. Böyle yani şu an saçmaladık da matematik endişesini ölçmenin bir metodu varsa yapabilirsiniz bu deneyi. Okay? Or do older people exercise significantly less frequently than younger people? Okay, this is another question. Do older people exercise less frequently than younger people? Okay, in this case, our independent variable would be age. So based on age, we can group people in two different groups. Or we can separate people in two different groups. For example, you can say maybe, okay, o da hangi yaştan ayıracağız mesela? Kaç yaşından sonrasında yaşlı, kaç yaşından öncesine genç diyeceğiz. Bu da önemli bir kriter olacaktır karşılaştırmak için. Mesela şimdi 40 yaş desek ben itiraz edeceğim. Ben 40'ın üzerindeyim, bana yaşlı diyemezsiniz diye. O yüzden bunu politik olarak doğru nasıl yaparız bilmiyorum. We have two groups, older people and younger people. And degrees of freedom would be the frequency of getting exercise. Mesela haftada ne kadar egzersiz yapıyorsunuz diye bir frekans ölçebilirsiniz. İşte bunları karşılaştırırsınız. Gençler şu kadar, yaşlılar bu kadar diye. Alright. Another example. Do 8th graders have significantly more unexcused absences than the 7th graders in Toledo junior highs? Ne demek bu? 8th graders yani 8'e gidenler, 8. sınıflar diyor. Have significantly more unexcused absences. Ne demek? Unexcused absence, okula ekmek. Sebepsiz yere gelmemek diyor. Yani 7'lere göre 8'ler daha mı bir fazla okulu asıyorlar acaba? Nerede? Bu okulda. Name of the school is Toledo Junior High. İşte Toledo High School'unda acaba 8'ler daha mı bir salmışlar 7'lere göre? Daha mı çok okula gelmiyorlar gibi. This is the question. In this case, our independent variable, again, we need to group them in students into two groups. It's already done for us. We have two groups, 8th grade students and 7th grade students. And the dependent variable would be the unexcused absences. Mesela bir dönemde kaç gün sebepsiz yere gelmediler. Mesela hani koronaya yakalandı gelmedi, onlar sayılmıyor. Yani hiç sebep yokken gelmedi. İşte orada çünkü gelmeyince de ailesine haber veriyorlar. Diyor işte, değil mi, arıyor demin, Mrs. Smith diyor, your son hasn't come to school today diyor. Mesela bugün oğlunuz gelmedi okula. Annesi diyor, eyvah diyor, ne yaptı diyor. Kötü yola mı düştü acaba diye. Bu şekilde hemen karşılığını almaya çalışıyorlar. Yani ailenin haberi var mı gelip gelmediğinden kontrol ediyor. Bu şekilde öğrenciler. Alright. Note that independent t-test can be applied to answer each research question when the independent variable is dichotomous, yani ne demek, iki seçenekli, dichotomous with only two groups, and the dependent variable is continuous. Alright. How are we going to solve these questions? Again, the same steps. First of all, we need to state the hypothesis. Stating hypothesis could be, again, a non-directional hypothesis or a directional hypothesis. Now, we learn about this now. Non-directional hypothesis would be the mean of the first group is equal to mean of the second group. Okay? In the directional hypothesis, for example, the mean of the first group is greater than or equal to mean of the second group. Okay, we have to put the equal sign to the null hypothesis. That's why we cannot get rid of this equality. Or other way around, first group mean value is less than or equal to second group mean value. Okay, so like in the other examples, also I will draw your attention to here. If it is non-directional, sorry about that. What happened? Oh, I forgot my pen. If it is non-directional, remember, we select an alpha level, right? If it is non-directional, you divide the alpha level by 2 and look at the t-table. Okay? If it is directional, you use your alpha level and directly look at the t-table. Okay? This is when you are supposed to divide the alpha or not divide the alpha. Okay? If your null hypothesis, or you can think of it, let me change it again. If your alternative hypothesis also, if it is directional, that means your null hypothesis is also directional, right? If it is directional, use the entire alpha in the t-table. If it is non-directional, that means there is like a complete equality or not equality, then select your alpha, and then, however, in the t-table, use the half your alpha in the t-table, okay, to find out your critical t-value, your tabulated t-value, okay? For example, the alternative hypothesis states that the two samples come from different populations. In other words, there is a statistically significant difference between the two groups on the dependent variable. Okay, for example, if your alternative hypothesis is non-directional, you get this kind of like mu1 is not equal to mu2. If your alternative hypothesis is directional, you have a direction. For example, in this case, mu1 is greater than mu2, or no, mu2 is greater than mu1. So it's either that way or either this way. All right. So because of this directionality, what do we use? Again, remember, you use your complete alpha when you go to your t-table. T-table. If it is not directional, not equal means it can be greater than, it can be smaller than. Right? Both of them are correct. In that case, you divide your alpha by 2 and then go to the t-table. All right. Again, remember that. Of course, what else you do? Set a criterion for rejecting H0 null hypothesis. For that, you need to compute your degrees of freedom, set your alpha level, which is easy, and then identify the critical T value. Okay, T critical. You can write it something like that. Critical. Find out your critical T value. By what? By using the degrees of freedom and by using the alpha level. Okay. Now, degrees of freedom is different in the, little bit different in the two-sample t-test. Calculate degrees of freedom to determine rejection region. In this case, degrees of freedom is calculated this way. N1, the number of n in the first group, plus the number of n in the second group, minus 2. Okay? Minus 2. Remember that always, minus 2. Why? 1 minus for the first group, 1 minus for the second group. All right? Degrees of freedom describe the number of scores in a sample that are free to vary. We subtract 2 because in this case we have 2 groups of samples. Bunu bu şekilde ezberleyebilirsiniz ya da öğrenebilirsiniz. 2 tane ayrı grubunuz olduğu için 2 çıkarıyoruz. Degrees of freedom'ı hesaplarken. Toplam örnek sayısından. Okay? In an independent sample t-test, each sample mean places a restriction on the value of one score in the sample. Hence, the sample lost 1 degree of freedom and there are n-1 degrees of freedom for the sample. So since we have 2 different samples, total we have n1 plus n2 minus 2 degrees of freedom in the sample, entire sample. Okay? Set the alpha level, which is, you can select any one of those. However, if you are not sure about it, go with 0.05, always a good idea. And then use this simple formula. Okay, this is the difficulty in two sample t-test. Okay, independent sample t-test. However, it looks, or the calculating the t might look like difficult, usually looking at this sample formula. However, it's very simple. So let's look at that. What is x1 bar? The mean value of the first group. x2 bar, the mean value of the second group. These are easy. What is here? S1 squared. What does that mean? This means the variance of the first sample. S2 squared, variance of the second sample. What are these? Very easy. The sample size of the first group, -1. Sample size of the second group, -1. And then all of the same. This is the degrees of freedom, n1 plus n2 minus 2, and times 1 divided by n1, 1 divided by n2. Okay, there is nothing unknown here. Just a lot of numbers, and then you are, I'm sure you are engineering students. These are very easy formulas for you guys. All right. At the end, what do? We compare test statistic to the criterion. Okay. For example, with the degrees of freedom 18, alpha level 0.05, two-tailed test in this example, for example, the critical values are 2.101. Okay, 2.101. Since it is two-tailed test, you use both minus and plus 2.101. Here, minus 2.101, plus 2.101. And then set the levels. Okay, these are the critical values, or the threshold values, you can call them, and then look at these are the rejection area, okay? The tails are the rejection area. And since this is alpha level 0.05 and two-tailed test, we know that this area is the probability of this area is 0.025, and probability of this area is also 0.025. What about this entire middle area? This is 0.95, okay? Because the entire area under the curve should be equal to 1, okay? In this case, after finding out the criterion, you calculate the T, this T statistics, and then put your T statistics here. If it is here, fail to reject null hypothesis. If it is here, fail to reject. If it is here, reject it. If it is here, reject it. Okay? This is very simple. If it is in the zero, right zero, what do? Fail to reject null hypothesis, right? We cannot reject the null hypothesis. Exactly. And after that, of course, based on your comparison, you make a decision. You either fail to reject the null hypothesis and conclude that there is no statistically significant difference. Yani ne diyor biliyorsunuz burada? Karşılaştırdıktan sonra eğer bir fark yoksa yani ne oluyor şu anda? Yani neticede tamam fark yok, bunu mu bulduk diyoruz. Bu kadar basit bir şey için mi yapıyoruz bu kadar testi? Hayır. Bu kadar testi istatistik bilimini arkamıza alabilmek için yapıyoruz arkadaşlar. İstatistik biliminin gücünden yararlanmak için, onu kendi tarafımıza çekmek için yapıyoruz. Yani ben tek başıma işte olcay olarak işte geldi rakamlar, tamam bunların arasında fark yok, gönder desem, iyi de sen kimsin? Yani şey misin bu, evliya mısın ya da bu konuda bir ne derler ona, söz sahibi biri misin? Nereden biliyorsun bu ikisinin eşit olmadığını? Sadece rakamlara bakıp bunlar eşittir, fark yok demek bir nokta, hani işte olca olarak cevap veriyorum. Ama bir de istatistik biliminin gücü adına, hani böyle var ya, He-Man var. İstatistik biliminin gücü adına diyorum ki aralarında fark yoktur diyebiliyorsunuz. Bunu yaparsanız. Yapmazsanız öyle bir rakamlara bakarsın. Ya bunlar aynı gibi ya dersin. Ancak bunu diyebilirsin. Başka bir şey diyemezsin. Alright? We can say no statistically significant difference between the two groups on the dependent variable. Okay? Or you can also, if you are in the highlighted areas, like these shaded areas, okay, blue ones, reject the null hypothesis and conclude that there is a statistically significant difference between the two groups on the dependent variable. Okay, and if it is indirectional, if it is directional, by the way, your alternative hypothesis, if it is directional, you can also indicate which group is higher or lower. Yani sadece işte aralarında fark vardır demezsiniz. Hatta bazen birinci grup, ikinci gruptan istatistik daha küçüktür ya da daha büyüktür de diyebilirsiniz. Yön de verebilirsiniz. Tabii bu neye göre? Depending on your alternative hypothesis, of course. Alright? Alternatif hipoteziniz yönlüyse eğer, for example, something like that, like mu1 is greater than mu2. Okay, this is your alternative hypothesis. And if you are here, for example, you are here, and you reject the null hypothesis, which was what? Your null hypothesis in this case would be mu1 equal to mu2, right? However, since this is greater than, smaller than or equal to, okay, this is your null. And since you are here, reject the null hypothesis and then go with this, and then you can say that the average, the mean value for the first group is statistically significantly greater than the mean value of the second group. Bu şekilde de cevap verebilirsiniz. Alright? Okay, I will stop here. And then for the remaining pages, we will have several examples also to help sync this t-test statistics information with you guys next week. All right, therefore I'm gonna stop here. This week it was quite a long course actually, and because last week there was no class, I was planning on making class last week, but we weren't able to. All right, guys. So görüşmek üzere haftaya. İyi günler.